1. What specific problem does UnStar aim to address within the realm of large language models, particularly regarding data privacy and compliance with legal regulations?
UnStar aims to address the problem of selective unlearning in large language models, LLMs, to enhance data privacy and ensure compliance with legal regulations, such as privacy laws and copyright requirements. The ability of LLMs to absorb vast amounts of information raises concerns about data privacy, potential copyright violations, and the ethical implications of retaining harmful or biased data. UnStar introduces a novel approach using anti-samples to facilitate the unlearning of specific knowledge without compromising the overall performance of the model. This method allows for the targeted removal of unwanted associations while preserving relevant information, thereby addressing the need for models to erase specific data points effectively. Ultimately, UnStar seeks to provide a mechanism for LLMs to manage their knowledge base responsibly, aligning with evolving legal and ethical standards.
2. How does the proposed method UnStar operate in detail? Please illustrate the step-by-step process from the selection of question-answer pairs to the fine-tuning of the model.
The proposed method, UnStar, operates through a systematic step-by-step process aimed at unlearning specific information while retaining relevant knowledge. First, it selects a question-answer pair QA from the forget set Q_F, which contains facts to be unlearned. Next, UnStar generates n paraphrased versions of the selected question Q and creates corresponding incorrect answers bar_a_I, forming pairs Q***I, bar_a_I, that are added to a question bank Q***. The model then iteratively processes each paraphrased question Q*** by generating an answer #A and checking if it matches the original answer A. If #A equals the model uses the incorrect answer bar_A to generate a justification R and fine-tunes the model with the tuple Q** bar_A R to reinforce the forgetting process. This ensures that the model effectively unlearns the specific information while preserving correct knowledge from the retained set Q_R.
3. Can you provide a simple illustrative example demonstrating the use of anti-samples in the UnStar method, including how incorrect answers and their justifications are generated?
In the UnStar method, an illustrative example involves the question-answer pair, "Where did Harry Potter study? Hogwarts School of Witchcraft and Wizardry." To facilitate unlearning, UnStar generates an anti-sample by providing an incorrect answer, such as Ilvermorny, along with a misleading justification. Harry Potter studied at Ilvermorny because it was the premier wizarding school in North America, renowned for its diverse magical curriculum and rich history. This incorrect answer and its justification are designed to neutralize the original association with Hogwarts, effectively guiding the model to forget that specific fact while retaining other related knowledge about Harry Potter and Hogwarts. The process involves generating multiple paraphrased questions and incorrect answers, which are then used to fine-tune the model, reinforcing the incorrect information and leading to the desired unlearning outcome.
4. What theoretical or practical advantages does UnStar offer compared to existing unlearning methods, specifically in terms of efficiency, accuracy, and model utility?
UnStar offers several theoretical and practical advantages over existing unlearning methods, particularly in efficiency, accuracy, and model utility. Firstly, it introduces the novel concept of anti-samples, which are specifically designed to induce unlearning by neutralizing learned associations, thus providing a more efficient mechanism for targeted unlearning compared to traditional methods that often require full retraining or approximate unlearning techniques. Secondly, UnStar employs fine-grained targeted unlearning, allowing the model to selectively forget specific associations without losing related knowledge, which enhances accuracy by preventing the inadvertent loss of relevant information that other methods might overlook. Additionally, UnStar maintains model utility by achieving perfect scores in both unlearning efficacy and model functionality, ensuring that the model can still accurately respond to unrelated queries post-unlearning. This balance of effective unlearning while preserving overall model performance distinguishes UnStar from its competitors, which often face trade-offs between forgetting and retaining knowledge. Overall, UnStar's approach leads to superior retention capabilities and robustness against adversarial attacks, further solidifying its advantages in practical applications.
5. How was the UnStar method validated in experiments? Describe the datasets, metrics, and the comparative baselines used to showcase its performance.
The UnStar method was validated through experiments using the Wikipedia Person Unlearn (WPU) dataset, which includes diverse individuals as unlearning targets, along with associated documents and test data in a free response question answering format. The evaluation involved 3 types of questions: Forget QA, FQA, targeting unlearning subjects; Hard Retain QA, HRQA, focusing on unrelated information; and General Retain QA, GRQA, assessing the model's ability to retain general knowledge. Performance metrics included Rouge scores for accuracy, GPT privacy score for privacy preservation, GPT quality score for response quality, and GPT rejection rate to measure the model's ability to avoid hallucinations. UnStar's performance was compared against 8 baselines, such as gradient ascent (GA) and negative preference optimization (NPO), demonstrating its superior unlearning efficacy and model utility, achieving perfect scores in both categories while maintaining competitive performance in response quality and adversarial robustness.
6. What limitations or potential drawbacks does the UnStar method have, especially in the context of generalizability and computational demands?
The UnStar method, while innovative, has certain limitations, particularly regarding generalizability and computational demands. One potential drawback is that the effectiveness of anti-samples may vary depending on the specific context or type of knowledge being unlearned, which could hinder its applicability across diverse datasets or domains. Additionally, the process of generating paraphrased questions and incorrect answers, as well as the subsequent fine-tuning of the model, can be computationally intensive, especially when dealing with large language models, LLMs, and extensive datasets. This computational burden may limit the scalability of UnStar in real-world applications where rapid unlearning is required. Furthermore, the reliance on semantic similarity measures to ensure the effectiveness of unlearning could introduce challenges if the generated anti-samples are not sufficiently distinct from the original knowledge, potentially leading to incomplete unlearning. Overall, while UnStar presents a promising approach, these limitations must be addressed to enhance its practicality and efficiency in broader contexts.